Alright everyone, so today's our first distance learning class. Just to start fresh, I'm calling this class 101. I know we skipped classes 85 to 99, or 86 through 99, but just to start fresh, we're going to start with class 101 here. It's a pretty straightforward class, just some introduction to electrostatics. That's the next unit, in unit 10. So our goal is to describe what gives objects electric charge and how we can charge them. All right, so describe what gives objects electric charge and describe how we can charge them. So the first thing I ask you to do is to draw a model of a helium atom. So a helium atom, just term from chemistry, is 2 protons, 2 neutrons, and 2 electrons. So let's do that first. I'm going to draw the protons in red. So there's one proton, there's another proton. I'll put little plus signs there. And we're going to do neutrons, we'll do them in gray. Something like that. So of course the neutron is in the middle of the nucleus is in the middle of the atom. We'll make it really small. And then we have 2 electrons because this is a neutral atom. So there's an electron there, there's an electron there. Obviously this isn't drawn to scale. And these kind of like zoom around in a circle around the atom. Now I know the whole idea of electron clouds, but for now we're just going to think of it as a circle. So the charge of a proton is positive, the charge of an electron is negative, and the charge of a neutron is neutral. Neutral. And the overall charge of this atom is going to be neutral as well. Now if this were an ion, we could add electrons or take away electrons to make it an ion to give it a positive or negative charge. So I kind of just touched on it, but how can I change the charge of the atom while still keeping it as helium? So some people have this idea of adding protons or taking away protons. We cannot do that, or else you completely change the atom. It's no longer helium. If you take away a proton, it's going to be hydrogen. What you can take away, though, and add are electrons. Okay, so how can I change the charge of this atom? You can only add or subtract electrons. Okay, that's a really important idea there. All right, so we're going to talk about electrostatics in this course. We're not going to do electrodynamics. So electro means electricity, and statics means stationary. So we are not going to do anything with electrodynamics where electrons or charged particles are moving around a lot. And there's a nice little picture. So there are 2 types of charges, positive. Actually, you know what? I'm not even going to write positive. I'm just going to write the plus sign. Positive and negative. Okay, opposites attract. And like charges repel. What do I mean by that? Positive charges attract negative charges. Negative charges attract positive charges. Negative charges repel each other. Positive charges repel each other. All right, things you've learned, in your physical science classes in middle school. All right, so I just want to look at this picture right here. So we have a before and an after picture. We're going to focus on the before picture. So look at this before picture. We have someone's shoes on a rug. All right. So the question asks us, the shoes and the rug are each neutral. How can you tell? Okay, how can you tell? Well, we can tell by looking here and saying, okay, positive and a negative, that's neutral. Positive and a negative, that's neutral, right? So I'll just write 0. All right, 0 there too. Then down here, well, let's see what we got. We have 1, 2, 3, 4 positives, 1, 2, 3, 4 negatives. So this is 0 or neutral as well. Okay. So how can you tell? Put that in your own words, but basically same number of positive charges as negative charges. Now, I included a little simulation for you guys from PhET. It's a pretty well-known one. We'll check it out to show this idea of what happens when you rub your feet on the carpet. All right, so this is called John Travoltage. It's one of the better known, one of the original PhET simulations. So what you can do with this is you can rub You rub John Travolta's foot on the carpet, and notice how he's gaining electrons. You don't see any movement of protons here. That's the important idea. And then
Ouch.
he can shock himself. All right. So, you can play with that simulation a little bit just to check it out. It's a little fun to play with. So let's look at the after picture. Which charges have moved? So let's look here. It looks like to me, well, if we look up here now, it looks like they gained an electron here. So that's like a -1, if you will. Gained an electron here, so that's kind of like a -1. And they lost 2 electrons from here. Notice how we still have the same overall charge. Okay, the overall charge before was 0. The overall charge now is still 0, -1, -1, and +2. So in the after picture, which charge has moved? Electrons. What is the resulting charge on the shoes? -1 each. What about the rug? +2. But just as before the rubbing occurred, the total charge in the system is still, like we said, 0. Or neutral, whatever you want to say. Now we'll quantify the charge a little bit more later. But for now, just think of it as positive charge, like +1, negative charge, -1. So what I want you to do is take a minute and check out this balloon demonstration, this YouTube video. I'll see if I can embed a link, but if I can't, you can access this PDF and just click on the link there. Okay, so I would pause the video right now, watch that video, and then come back to this in just a second. All right, so hopefully you watched that video, and the question that comes up is, how does the balloon pick up the pieces of paper? And a lot of people have these different ideas about how that happens. They say, oh, there's charged particles. When you rub the balloon, it gets charged. But here's a problem, and what a lot of people don't notice. Now, we said positives attract negatives. We said negatives attract positives. But what about neutral objects? How does a balloon, if it's charged, attract these neutral pieces of paper? Okay, if I rub a balloon on my shirt and stick it to a wall, how does a balloon attract a neutral wall? All right, and this next PhET simulation, I think, does another really good job of showing what happens there. All right, so let's click on this. All right, so in this simulation, you don't have to change any of the settings, but what you can do is take a balloon, bring it to the wall. Notice it does not stick to the wall. All right, it just kind of hangs out there, but it's not necessarily sticking or attracted to the wall. Okay, so I'm going to rub it on a sweater, like a wool sweater. Notice how it took electrons from the wool sweater. Okay, we did not change, or we did not take protons, we didn't move protons, none of that. Now look at the wall carefully as I bring the balloon near it. What's happening to those electrons in the wall? Okay, notice how the wall, the electrons are moving away from the surface because they're repelled by the electrons in the balloon. The electrons in the balloon have nowhere to go. They're on the balloon. But the electrons in the wall, they can move away from the surface. Now, this is a bit exaggerated. They're probably only moving away on the scale of nanometers or micrometers. But it is enough to make a difference. And we can see now the balloon is negative. The surface of the wall is positive, so it sticks to the wall. All right. And it also sticks back to the sweater, right? Because the sweater lost those electrons. They're now stuck on the balloon. And you can do a few other things with this app. You can have 2 balloons. If we reset the balloons, I can get some negative on the balloon. I get some negative on this balloon. Notice how the 2 balloons, they kind of repel each other. So you can play with those a bit. All right. Now let's get back to notability. Okay, so let's try to answer about why the balloon picks up the pieces of paper. How does that happen? So in C it says, remember, the paper is neutral. How can something with charge be attracted to something that is neutral? Draw a picture in the space below. So I'm going to draw 2 pictures. I'm going to draw before rubbing the balloon. I'm going to draw after rubbing the balloon. Okay? So let's do our before picture here. Okay, so before rubbing the balloon, make the balloon red. And we'll make the paper gray so it's easier to see. This is just one piece of paper. Okay? Now the balloon is neutral. So I'm going to put like positive, negative, positive, negative, positive, negative. So it's neutral, as is the paper. So I'll go positive, negative, positive, negative, positive, negative. All right? Now, let's go to the after picture. So in the after picture, I'm going to rub balloon. Now the balloon looks a little bit different. So I'm actually going to, so the part of the reason I want to use Notability to do this stuff was it just makes drawing some of these pictures way easier. So I already have my after picture there, just copy and pasted it. And I'm going to write after. Okay. So after I rubbed the balloon, what did I do? Remember, we added electrons to the balloon. Where did we add them from? We added from like our hair somewhere else. Okay. So we'll just throw some extra electrons on here. There, 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 there. So the balloon is definitely negative now. Okay, got all those extra electrons from our hair or from our sweater, whatever we rubbed it on. So now as we bring the balloon closer to the paper, just like bringing the balloon closer to the wall, what's going to happen to those electrons in the paper? The electrons in the paper, as you may have guessed, are going to move to the opposite side. They don't like the electrons in the balloon. So now, the balloon is negative. The left side of the paper is positive. So they're going to attract each other. Okay? Now you might be saying, oh, so now are some of those electrons in the balloon going to go to the paper? To an extent. We'll get into that a little bit later. But for now, what I want you to understand is that a negative object can attract both positive objects and neutral objects. Okay, a lot of people forget about that and neutral objects part. And this is how they do it. You push the electrons to the far side, making the near side more positive. So I'm also going to try again to embed a link to these couple of videos here, but I think these are really good. This video in part D shows how you can move a soda can back and forth using a charged rod. And then number 6 is just a video of Bill Nye doing some electricity stuff. So just a little aside, so Ben Franklin used to think that positive charges were the charges that transferred from one object to another. Hopefully you realize that's wrong now, right? It's electrons or negative charges that are transferred from one object to another. Now, this is going to be a little bit annoying later on because what happened was Ben Franklin and other scientists started using this idea that positive charges move. Well, then people started making circuits and learning about electricity, and they thought that positive charges move. So actually what you'll find is when we go to circuits, we pretend that the positive charges move. It still works. The circuits are fine. I mean, even electricians, electrical engineers still do that. But just keep that in mind when we get there later, that's a convention we're going to use. But just know that only the negative charges move, the electrons. The positive charges, the protons, those are stuck. All right, so let's look at a little practice question here. I think this is similar to one that's on your exit ticket for today's class. So as a student runs a plastic comb through her hair, the comb acquires negative electric charge. This charge results from the transfer of, we have all the different choices, just take a second to read those. So just from a test taking's perspective, think about which two choices you can eliminate immediately. And those two choices that you can eliminate immediately are choice 1 and choice 2. Protons don't move. They're not transferred. So now we narrowed it down to choices 3 and 4. Okay, so the comb becomes negative. Okay, so if the comb becomes negative, the comb must have gained electrons. From where? They have to come from somewhere. From her hair. So let's say electrons transferred from the comb to her hair? No, the comb got the electrons. So electrons are transferred from her hair to the comb. So that'd be choice 4. So you have a few questions on your exit ticket to answer about some of the stuff, but just keep in mind when you get to that exit ticket, like charges repel, opposites attract, but remember, charges can also attract a neutral charged object. Okay, that's a really important idea. And keep in mind that only electrons move. Okay, if you keep those things I just said in mind, you should be able to have no problem answering those questions. All right, and just to let you guys all know, like, what am I using to make these? I'm using the iPad screen record function. So I'm recording right now so you can see everything. And I'm using an app called Notability on my iPad. It's not a free app, but if you have an iPad and you want to spend $10 or whatever it costs for this app, it's not a cheap one. I think it's a well worth it app, but you're in no way required to do that. Also, if you're wondering, am I supposed to be taking notes on these? Should I be printing them out? What should I be doing? It's up to you how you want to do it, but you should be taking notes. If you want to print it out, I know it's going to be a lot of paper. You're welcome to print it out and just write along with me. If you want to download it and annotate a PDF, that's fine. If you want to take physical notes on a piece of paper, that's okay too. Just keep in mind that there will be times, not in today's class, but there will be times when I ask you to submit some questions from class. I didn't for this one because there's really not a lot of math to do, but there will be times when I say, hey, when you drew the pictures on number 5, part C, please upload a picture of what you drew so I know you have a good drawing. So be prepared to do something like that. Okay, but it's up to you how you want to take notes, but keep in mind you do have to be ready to upload some stuff at some point. So whatever you want to use to do that, make sure you're comfortable doing it. All right? If you have any questions, feel free to email me, and I will be having extra help Tuesday at 2:30. Okay, I'll post the info for the Google Hangout there. All right? Have a good one.